All right, so you're ready to take on the Java Collections framework, huh?
Yeah, we're going to dive deep into how Java handles, well, groups of objects.
Perfect. I think this will be really helpful for anyone,
Yeah.
if you're prepping for an interview or maybe getting ready for a project, or
Yeah.
even if you're just curious about
Yeah.
this fundamental part of Java.
Absolutely.
And, we're going to really try to make these concepts click.
That's right. We're going to go beyond just definitions.
Yep.
We'll talk about when to actually use each collection type and what the trade-offs are involved.
Awesome. So first things first, what is the Java Collections framework?
So think of the Java Collections Framework, or JCF, as like a toolbox. It's a toolbox that's specifically designed to handle groups of objects in Java.
Okay, so it's like having a set of specialized containers, I guess, for different situations.
Exactly. Like if you need to store a bunch of names or maybe keep track of customer orders, the JCF has a container that's going to be perfect for pretty much any need.
That makes sense. So what kind of containers are we talking about here?
Well, at the top level, we have the collection interface.
Okay.
That's the grandparent of them all.
Okay.
From there, we branch out into a few different types. Each one has its own, personality and purpose. Lists, sets, maps, queues, and decks.
Wow, that's a lot of options.
Yeah.
It's almost overwhelming. So how do you know which one to use when?
Yeah, it can definitely seem like a lot, but that's why it's so important to understand the strengths and weaknesses of each one.
Right.
So let's start with lists. Lists are all about, keeping things in order.
Hmm?
The elements are stored in a specific sequence, and they can have duplicates.
Okay.
So imagine your to-do list. You might have buy groceries on there twice,
Yeah, for sure.
just to make sure you don't forget. And in Java, array list, linked list, and vector are all common ways to create lists.
Okay, so lists are the organizers, always keeping things in check. What about sets? Where do they fit in?
Sets are kind of the opposite of lists in a way. With sets, it's all about uniqueness. No duplicates allowed. Think of it like a guest list for a really exclusive party.
Right.
You only get one invitation per person.
Makes sense.
And, to make these sets, we use hash set, linked hash set, and tree set.
Got it. So lists are all about repetition, and sets are about exclusivity. Now, what about those maps I keep hearing about?
Maps. Maps are all about connecting things. They link keys to their corresponding values. Like think of the contacts list on your phone. Each name is linked to a specific phone number.
Right.
That's essentially what a map does. And we have a few different implementations for creating them, like hash map, linked hash map, and tree map.
So maps are the master melting tickers of the collection world. What else do we have in this toolbox?
Well, we also have queues and deck.
Okay.
Queues are designed to hold elements in a specific order until they're processed. It's like a line at the bank, first come, first serve.
Right. First in, first out.
Exactly. We can use things like priority queue and array deck to implement queues.
And what about decks? Are they similar?
Decks, or double-ended queues, are kind of like a train with doors at both ends. You can add or remove elements from either the front or the back, which makes them a little more flexible than standard queues. And we usually use ArrayDeck to implement a deck in Java.
All right. So we have lists for order, sets for uniqueness, maps for pairings, and queues and decks for managing those lines. It really is like a whole world of organizational possibilities.
It really is, and that's just the beginning. Things get even more interesting when we start comparing these collection types head to head. Really looking at the performance trade-offs of each one. For example, let's talk about the battle of hash map versus concurrent hash map.
Oh, a head-to-head matchup. I'm ready for this.
Yeah.
Let's see how they stack up.
All right, so imagine you're working on this project where multiple parts of your code are all trying to access and modify data at the same time.
Okay.
It's like having a bunch of chefs all trying to work in the same kitchen at the same time. Things could get pretty messy if everyone's not careful.
For sure. Someone's going to end up with a half-chopped onion.
Exactly. And in the programming world, these chefs are called threads. And this whole situation is what we call a multi-threaded environment.
So how do HashMap and concurrent HashMap handle all of that activity?
Well, the thing is, HashMap isn't really built for this kind of multitasking.
Oh, no.
It's not what we call thread safe, which means that it can't really guarantee that the data won't get messed up if multiple threads are trying to access it at the same time.
So it's like all those chefs fighting over the same cutting board?
Exactly. It's a recipe for disaster.
So how does concurrent hash maps save the day?
Well, concurrent hash map is the superhero in this scenario. It's designed specifically for these multi-threaded environments, and it uses this clever technique called segment-based locking. It's like if we divide the kitchen into different stations, so each chef has their own space to work in.
Oh, okay. So instead of everyone fighting over the same cutting board, each chef has their own designated area.
Precisely. They only share resources when it's absolutely necessary.
That's a pretty neat way to keep things running smoothly. But how does segment-based locking actually work?
It can get a bit technical,
Yeah.
but basically, concurrent hash map takes the map, right, and it divides it up into smaller segments,
Okay.
and then each segment gets its own lock. So this means that multiple threads can actually access different segments at the same time without interfering with each other.
Oh, I see.
But if two threads need to access the same segment, then only one of them can get the lock at a time. This ensures that all changes are made in an orderly fashion.
So concurrent hash map is like that super organized kitchen, with designated workspaces and a system for managing those shared resources. That makes a lot more sense. But what about hash map? Does it have any advantages over concurrent hash map?
Oh, absolutely. If you don't need to worry about thread safety, then hash map is generally going to be faster than concurrent hash map. It's like having just one chef in the kitchen. They can move around freely and get things done much quicker because they don't have to coordinate with anyone else.
Yeah, that makes sense.
So, if you're working on a single-threaded application, hash map is often going to be the more efficient choice. Plus, it's much simpler to understand and use.
Okay, so it's a trade-off. Speed and simplicity with hash map versus safety and reliability with concurrent hash map. I'm starting to see how these subtle differences can really affect how your code performs.
Exactly. It can even help you avoid some really frustrating bugs down the road.
Right. So what other collection comparisons can we look at? Okay, so we've talked about some of the big players in the Java collections framework: lists, sets, maps, queues, and decks. And we even had that head-to-head between hash map and concurrent hash map.
Yeah.
But how do we actually work with these collections in our code? Like, how do we get to the elements inside, change them, and keep everything organized?
Well, that's where iterators come into play. They're kind of like our guides. They let us move through the elements in a collection without needing to know how it's structured underneath.
Oh,
It's like imagine taking a tour bus through a new city. You don't need to know the exact route or anything to enjoy the sights.
right. That makes sense. So an iterator is like our personal tour guide, taking us through all the interesting parts of a collection. How do we actually use them in our code?
It's actually pretty straightforward. You just call the iterator method on your collection,
Okay.
and that gives you back an iterator object. Then you can use a couple of handy methods like hasNext to check if there are more elements to look at, and next to grab the next element in line.
So it's kind of like hopping on the tour bus, checking if there are more stops, and then getting off at the next one.
Exactly.
That's a great analogy.
Yeah.
So can we use an iterator with any collection? Lists, sets, maps, all of them.
Yep. It's a really versatile tool for working with collections. And if you need even more control over how you move through the collection, we have a special type of iterator called list iterator.
Oh. A specialized iterator. Tell me more about this list iterator. What makes it so special?
Well, with list iterator, it's like you have a more interactive tour bus.
Yep.
You can not only go to the next stop, but you can also go back to a previous one. It gives you methods for moving both forwards and backwards through the list.
So it's like having a rewind button for our list reversal. That could definitely come in handy.
Absolutely. And there are a couple of other things to keep in mind with iterators, like the difference between fail-fast and fail-safe iterators.
Oh, okay. I remember we talked about the potential issues of changing a collection while another thread is iterating over it, right?
Exactly. And that's where these types of iterators come in. Fail-fast iterators are kind of like strict museum guards.
Okay.
If they see any unauthorized modifications happening during the tour, they immediately sound the alarm.
So they're really focused on maintaining order and preventing anything from messing up the collection.
Exactly. And they do this by throwing a concurrent modification exception. It's their way of saying, hey, something's not right here.
Makes sense.
Yeah.
So what about the fail-safe iterators? How do they approach this whole situation?
Fail-safe iterators are a bit more relaxed. They actually work on a copy of the collection, like taking pictures of the exhibits instead of actually touching them.
Ah.
So even if the original collection changes during the iteration, the fail-safe iterator won't even notice. No exceptions thrown.
So it's like having a souvenir photo album. You can browse through it without worrying about damaging the actual exhibits. I'm starting to see how important these different types of iterators can be. It seems like they can really help us avoid some major headaches when it comes to concurrency and data integrity.
Absolutely. It all comes down to choosing the right tool for the job. Fail-fast iterators are great for catching those potential concurrency issues early on, while fail-safe iterators give you more flexibility and stability when you know there might be concurrent modifications happening.
This is feeling like we're putting together a whole toolkit for navigating the world of Java collections.
Mm.
We've got our different collection types, our iterators for traversing them, and now we're even thinking about how to handle concurrency and keep our data safe. What else do we need to add to our arsenal?
Well, we can't forget about synchronization. This is a crucial concept for making sure our collections behave correctly when we're working with multiple threads. Remember how we talked about concurrent hash map being thread safe?
Yeah, it's like our kitchen superhero, making sure all the chefs could work together peacefully.
Oh,
But what about the other collection types? How do we make sure they're thread safe if we need to use them in a multi-threaded environment?
well, Java actually provides a few different ways to synchronize collections. One common approach is to use collections.synchronized collections.synchronize set, or similar methods. These basically create synchronized versions of our regular collections.
Hmm.
It's kind of like adding a security guard to the museum entrance. They control the flow of visitors and make sure that only one person can interact with an exhibit at a time.
So we're adding this extra layer of protection around the collection to prevent any chaos from multiple threads trying to access and change data at the same time.
Precisely. Synchronization is a super powerful tool for maintaining data consistency and preventing those nasty race conditions that can lead to unpredictable behavior in our programs.
This deep dive into Java collections is really opening my eyes to how much thought goes into handling groups of objects effectively. We've talked about iterators, fail fast versus fail safe, and now synchronization for thread safety. It feels like we're building a really solid foundation for mastering this whole world of Java collections. What else is there to explore on this journey?
Well, now we can delve into something that's really interesting. The difference between shallow copy and deep copy. It might seem a bit abstract at first, but it plays a crucial role in how we manage the data within our collections.
Shallow copy versus deep copy. Sounds like we're about to have a philosophical debate about the nature of reality.
Yeah.
I'm intrigued. Can you break down this distinction for us?
Imagine you have a blueprint for a building. A shallow copy of that blueprint would be like making a photocopy. You have a new sheet of paper, but it's still referring to the same underlying design. If you change the original blueprint, those changes will also show up on the photocopy.
Okay, so a shallow copy is like a mirror image. Changes to the original are mirrored in the copy. What about a deep copy? How's that different?
A deep copy is more like taking that blueprint and creating a whole new set of drawings based on it. Now you have two totally independent blueprints. Changes to one won't affect the other at all. It's like having two separate teams of architects, each working on their own version of the building.
Ah, so a deep copy is like creating a separate entity, completely independent from the original. But how does this relate to Java collections? We're not dealing with blueprints here, are we?
Not literally, but the idea is the same. When we're working with collections that have objects inside them, especially mutable objects,
Yes.
the ones that can change, then understanding the difference between shallow and deep copying is really important.
Okay, I think I see where you're going with this. So if we have a collection of objects and we make a shallow copy, we're essentially creating aliases,
Yeah.
right? Multiple references all pointing to the same objects in memory.
You got it. And this can be a bit tricky if we're not careful. Let's say you have a list of person objects, and each person has a name and an age. If you make a shallow copy of that list, and then you change the age of a person object in the original list, well, that change will also show up in the copy because both lists are actually pointing to the same person object in memory.
Whoa, that's kind of mind-bending. So with a shallow copy, we're not really creating new objects, just new references to the existing ones. It's like having multiple pointers on a map that all lead to the same location.
That's a great way to put it. And this can cause some unexpected problems if we're not aware of it. Deep copy, on the other hand, actually does create brand new objects. So any changes to the original won't affect the copy and vice versa. It's like having two separate maps with their own sets of location.
Okay, that makes a lot more sense. Deep copy gives us true independence, making sure that changes in one collection don't have those ripple effects on other parts of our code.
Exactly. Understanding this difference between shallow copy and deep copy is so important for keeping our data clean and avoiding those weird bugs that can pop up from sharing objects unintentionally. We need to be mindful of how our collections interact and how changes in one area might affect others.
This deep dive is really revealing all these layers of complexity that I never even considered before. We've gone from the basic types of collections to iterators, synchronization, and now this whole concept of shallow and deep copying. I feel like we're building a rock-solid foundation for understanding Java collections. What else can we add to our toolkit?
Well, next up, we can explore how to bring some order to these collections using comparable and comparator. Get ready to dive into the world of sorting and see how we can arrange our elements just the way we want them.
Okay, so we've covered a ton when it comes to Java collections. We've talked about different types, ways to navigate them with those iterators, and even how to make sure everything's safe when we're dealing with multiple threads using synchronization. And wow, we even went into that whole shallow versus deep copying thing. But now I'm kind of curious, how do we tell Java how we want our collections sorted? How do we put things in order?
Well, that's where comparable and comparator come in. They're basically our sorting assistants, helping us arrange our elements exactly the way we want.
Okay, so they're like the organizers of our collection universe. Tell me more. How do these sorting assistants actually work?
Think of comparable as the set of rules that objects just naturally follow, like a built-in rule book.
Okay.
If a class implements that comparable interface, it means those objects know how to compare themselves to each other.
So they just like inherently know their place in the world.
Pretty much. A good example is strings. They naturally sort alphabetically, right?
Yeah.
That's because the string class in Java, it implements comparable. And its compare to method, that's what defines that alphabetical order. So when you have a bunch of strings and you want to sort them, they just line up alphabetically without you having to do anything special.
That's pretty cool. So they just like instinctively know how to arrange themselves?
Yeah.
But what if we want to sort things differently? Not just alphabetically or in their natural order. What if we have like a specific way we want to organize things?
That's when comparator comes in handy. It's like having a custom rule book that we create to override the default sorting.
Oh.
With comparator, we can define our own logic for how to compare objects. We decide how they should be arranged, regardless of their natural order.
So comparator gives us the control to make our own sorting rules.
Exactly.
That's awesome. Can you give me like a real world example of how we might use this?
Sure. Imagine you have a collection of person objects, right?
Okay.
And each person has a name and an age.
Right.
Now, let's say you want to sort them by age instead of by name. You can make a comparator that specifically looks at the age property of each person. Then, boom, you can use that comparator to sort your collection, and you'd have a list of people arranged from youngest to oldest.
Okay, that makes a lot of sense. So comparable is like the default sorting, and then comparator lets us get creative and customize how we want things sorted. I'm really starting to see how these tools can help us keep our collections neat and tidy, no matter what kind of data we're dealing with.
Exactly. Whether you're sorting customers by their purchase history, organizing products by price, or even just prioritizing your to-do list, comparable and comparator give you the power to get that perfect order.
Wow, this deep dive has been amazing. We've learned about so much, the different types of collections, those handy iterators for moving through them, how to keep everything safe with synchronization, and even the whole concept of shallow and deep copying.
Yeah.
And now on top of that, we have these tools for sorting. I feel like I have a much deeper understanding of how Java handles groups of objects.
I'm glad to hear that. You've got a really solid foundation for working with Java collections now. And my advice, keep experimenting. The more you play around with these concepts in your own projects, the more comfortable you'll become.
Yeah, that's great advice. Don't be afraid to try things out, right?
Yeah. Try out different collection types, play with those iterators, see how synchronization works in practice, and have fun sorting things in different ways. It's all about getting that hands-on experience.
And for all our listeners out there who might be just starting to learn about Java collections, what's the most important thing to remember as you begin this journey?
Honestly, the most important thing is to just dive in and start experimenting. The more you try things out, the more you'll learn.
Absolutely. Don't be afraid to make mistakes. That's how we learn. And, even though it can seem a bit overwhelming at first, with a bit of practice and the sense of adventure, the Java Collections framework becomes an incredibly powerful tool for any Java developer.
Couldn't have said it better myself. It's really a testament to how well-designed Java is. It gives us the tools we need to build some pretty amazing things.
Thanks for joining us on this deep dive into Java Collections. Until next time, happy coding, everyone.